Here's another example of using a trapezoidal sum to approximate area under a curve. So we've been asked to compute the area of a cross-section of the river. We know area is distance times height. So that's what I have here, a distance, marker here, distance times a height. The problem is the depth of the water is not a constant, so I'm going to have to let it change over time, just like I have to now let velocity change over time. Velocity, I've come to recognize, isn't always a constant. I can still find these areas, and I'm going to use trapezoids to approximate that area. So I'll write it out. First, notice I've been asked to use 4 subintervals, and again, they're not trying to trick you. That's going to be 1 subinterval, 2, 3, 4. And each time, each one of my trapezoids is going to have the distance across, which is the difference between the input values, the distance across the interval, and then I'm going to multiply by the average of the 2 heights. They're the 2 heights that would have been my left hand and right hand rectangle values, but I'm going to average the 2 together. So I wrote this out very carefully so that you could get used to my pattern. Feel free to do the math in whatever order works for you. So this is the sum of the 2 heights, 0 plus 7, divided by 2 because I want the average, multiplied by 8. 8 is the distance across that time interval. Then my second trapezoid, I'm going to take the sum of the 2 heights and find the average, multiplied by the distance across that interval, which is 6. So you can add this all up. Every time I'm multiplying a height, which is measured in feet, times the distance across the interval, which also happens to be measured in feet. When I multiply feet by feet, I get feet squared. This turns out to be 115 square feet. All right, so just so you understand the error that occurs when we use trapezoid sums, I draw this picture for myself all the time. Feel free to draw it for yourself. This is a picture of a parabola, an upside down parabola, just concave down, right? Notice what happens when you try to draw a trapezoid inside it. Ends up looking like a rectangle in this case. But you can see that that trapezoid is an underestimate of the area under that parabola. So that's how we determine error in a trapezoid sum. A trapezoidal approximation of the area under the graph of f is an underestimate. Sorry about my typing. When f is concave down, here's a function concave up. You can see that when you draw the trapezoid in there, that's too much trapezoid. That's going to be an overestimate whenever f is concave up. All right, so let's try this example. Use 3 trapezoids of equal width to approximate the area under the curve y equals x cubed from x equals 0 to x equals 6. Is our answer an overestimate or an underestimate? The only way we're going to be able to justify that answer is to check the concavity of f. So let me make a picture. All right, so once I get that picture in, I've been asked to take 0 to 6 and split it up into 3 sections. So that means each section is going to be 2 spaces wide. Here's my graph of y equals x cubed. I'm going to write the areas of my trapezoids. So here I've written out a sum for my trapezoids. Each interval is exactly 2 wide, which is why I have all of these 2's here that are multiplying. These other parts of the expression are the average of the 2 heights of the trapezoid. So height plus height divided by 2. And I get, this area is approximately equal to 360. So now we want to answer this second question. Is that an overestimate or an underestimate? The answer has to come from checking the concavity of f. So here's my final answer. I've determined that f double prime is 6x, which I know is positive on the interval 0 to 6. So I can say 360 is an overestimate of the true area because y equals x cubed is concave up on the interval 0 to 6.